Find the specific solution to the differential equation y prime plus 4y over x equals 10, whose curve passes through the point 1, 0. So this gives us an x and the corresponding y. That should allow us to determine a specific solution amongst the general solution, which is a whole family of possible answers. And we're going to first find the general solution, then we'll find this specific solution. So let's look at this differential equation. Now, it is a linear differential equation, and we can, is it minus or plus? It's plus. We can emphasize that by writing this with 4 over x and then a y here. Okay, so this fits the linear differential equation mold. Okay, so how do we go about solving these? Well, first we need to find an integrating factor. Okay, the integrating factor is of the form e to the integral of some p of x. And that's why you do need to double check, is it plus or minus, because that can alter your p of x and therefore change your integrating factor. So in this case, our p of x is 4 over x. So e to any antiderivative of 4 over x should do the trick. So 4 ln x, that's fine. And we could leave it like that, but e and ln, they kind of cancel out, and so we'll be left with x to the power 4. So that's going to be our integrating factor. Once we've got our integrating factor, we go ahead and we multiply everything by our integrating factor. We'll simplify in a moment. So 10 times x to the 4. Okay, so we can cancel out an x here and get a 3 here. So why do we do this? Why do we do this rewrite for our equation? It's 10x to the 4 over here. Well, the whole reason is so that we can reverse product rule and turn this into whatever the integrating factor is times y. Well, the derivative of that specifically. So the derivative of integrating factor times y, because we know how to cancel out differentiation. You just integrate both sides. So you integrate, you'll get x to the 4y here, and then we just integrate 10x to the 4 here. Well, okay, that's x to the 5, and you'll be left with a 2 here. Don't forget your constant, because we want the general solution. And there we go. X to the 4 times y is equal to 2 x to the 5 plus c. Divide by x to the 4 on both sides, and we have our general solution. And that simplifies to 2x plus c over x to the 4. Great. So for different values of c, you get different functions for y in terms of x. We're looking for one very particular one. We want, what is it? Y is going to be 0 when x is equal to 1. So if we take this and change all the y's to 0s and all the x's to 1s, this should give us a nice equation that allows us to solve for the specific constant c that gives us what we need. 1 to the 4 is just 1, so c over 1 is just c. And we can see, our constant should be -2. So, putting this all together, the specific solution we want is y equals 2x plus c, but that's going to be -2. So we'll say minus 2 over x to the 4. Or I suppose you can write it lots of ways. You could say minus 2x to the -4. Or you could say 2 times x minus x to the -4. Any of these are fine. I like this one. I like this one. This one. The third one I wrote was just because I was thinking of variations, but definitely the first two are my preferred way of writing the specific solution that we're looking for.